Hey everybody, welcome back. In this video, we're going to be exploring transistors. As with every new component, we're going to take a few minutes to first learn a little bit about what is a transistor, how do you set it up, how do you use it in a circuit, and then we'll look at a build example. Transistors are electrical switches that we can control with a signal from an Arduino. They're three-legged components. You're going to find them in the foil bag in your kit. The symbols in the upper right-hand corner here. The three legs are called the base, collector, and the emitter, and we're going to check out what those do for us in different circuits. When you open up that foil bag, you're going to notice that there's a handful of small components that all look really similar. There's two types of components in that bag, TIP 122s and 7805s. Even though they both have what is called a TO220 package, which is this three-legged device with a metal tab on the back, they're really different functionally. So it's important that you identify the TIP 122s for building in this video. The TIPs have notched corners on the top, not square corners. They have little divots or notches out of their black body, and they say in really tiny, impossible to read font, TIP 122 in the upper left-hand corner of that black body. So make sure you track down the right components, notched edges, notches on the body, find the TIP 122 label, and you'll be ready to build. In the world of transistors, there's two main types, NPNs and PNPs. We're not going to get into all the nuances and different kinds and what all of that means, but it is important to know that the TIP 122 is an NPN transistor, and that will tell us how to set it up and how to work with them. We also need to know that NPN transistors get connected to the negative side of the circuit that they're switching, and that will make sense when you see the schematic in just a moment. And the last thing we need to think about is that an NPN transistor turns on or connects its circuit to ground when we give it a positive signal. So here's a sample schematic. It looks like a lot, but if you pause and just consider all of the components and break it down, you're going to see that you know most of it. If we start at the top right, there's the +5 symbol. So that means we're going to be connecting to the 5-volt rail, that 5-volt power that we draw from our Arduino. Resistor LED combination, super familiar with it. So that's the circuit that we're going to turn on and off, a resistor and an LED. The transistor is that circle component down towards the bottom with the B, C, and E, base, collector, and emitter legs. The emitter leg, labeled E in the schematic, gets connected to ground. And if you look at the drawing of the component, you'll see that the legs there are labeled as well, B, C, E. There's no way to know that they're B, C, E. You actually have to look it up on something called a data sheet. And we'll talk about that in class. The last leg is the base, and it gets connected to an Arduino pin through a current limiting resistor. Here we've got the same schematic on the left, indicating that we're connecting to Arduino pin 8, indicating that the two resistors in this circuit are going to be 1K resistors. And on the right, we have a fritzing diagram with an insert of the TIP 122 to remind you that the legs go base, collector, emitter. Before we build this circuit, we need to make sure we've got the right component. You have two components in your silver bag that come in this package. This is called a TO220 package. And despite looking very similar, they're very different components. You want to find the ones that indicate they are TIP 122s, as you see on the left side of your screen. The lettering is incredibly teeny, and it can be quite difficult to read. So in addition to the label, and the label is the only thing that you can really count on, you should be able to see that there are some divots in the black body of the component on the left. This is the transistor. The component on the right is a 7805, and you can see that marked on the bottom here. The transistor has the divots here, and it also has the corners notched out. The 7805 has square corners. So the transistor, notched corners, notched body, says TIP 122, just as it does in this tiny little view right here. And you want to make sure you get those in your circuit, or this build isn't going to work. All right, now that we're sure we know that we've got the TIP transistor, remember, notched body, notched corners, TIP 122 on the label, we're ready to start this build. Zoom in on the breadboard so we get a good view of what we're about to do. Fritzing diagram, and schematic tell us that the first thing we need is a connection to the middle leg of the transistor that will connect to the circuit we're going to control. And I'm going to use this red wire for that connection. And I'm going to put it on now because when I put the transistor in, it's going to obscure your view. Transistor is a 3-leg component, and the middle leg needs to connect to the circuit that's being controlled. So I'm going to place that there with the middle leg connected to this red wire. The right side of the circuit has a ground connection, so the right leg of the transistor gets a short wire connected to ground. The circuit we're controlling goes above the gate divide on the breadboard, and it's going to be connected to that red wire. And the circuit we're controlling is a simple LED. I'm going to plunk that in there. And as always, the LED needs a current limiting resistor, which we will connect to the long leg and make sure we connect into the 5-volt rail at the top of the board. Tweak that back a little bit so hopefully you can see that its leg is connected to the red wire. So the transistor is acting like a switch on the ground side of the circuit. The rest of the circuit's up here. The control signal will ultimately come from the Arduino, and it needs a current limiting resistor connected to the left pin, the left leg of the transistor. If we remove the transistor for a moment, just to see that, we've got the resistor in one column, then the red wire, then the black wire. Our control signal will then get connected to this current limiting resistor here, and in a moment we'll connect that to our Arduino. We're going to make our power connections onto the power headers of the Arduino, red wire into 5 volts, black wire into ground. Let's connect those onto the power rails of our breadboard, black wire onto ground, red wire, we can put it up here for fun. Now that's going to cross the Arduino. Red wire onto the red rail at the bottom. All the red tie points are connected to this jumper. All right, let's power this circuit up. Green indicator light on the Arduino to indicate that we've got power. Before we connect some code, I just want to look at how we can manually control this circuit. I'm going to take the yellow wire and I'm going to connect it to the 5-volt rail. And when I do that, the LED turns on. And it's important to understand that it didn't turn on because I put power into the circuit through the yellow wire. Instead, I took 5 volts through this current limiting resistor, which is connected to the left signal pin of the transistor, to the base of the transistor. When the base receives that little bit of current and power, it closes a switch between the collector, which is the red wire, and the emitter, which is the black wire, and allows current to flow through the circuit up here that we're switching with the transistor. When I remove that signal from the base, the LED turns off. If I connect that signal to ground on the blue rail, the LED stays off. And when I give it that positive signal, so when I give it the positive signal on the base, switch closes, circuit is on. Let's see if we can do that with code now. I've already uploaded some digital output code. It's in fact the code we developed in weeks 3 and 4 when we were working with LEDs and blinking them directly. And so this is a digital write high and then low, sending a signal to the base, closing the switch and effectively turning on this circuit. Now you might be thinking, Jesus, Steve, that was a lot of work to blink an LED. We could have done all that without the transistor. And you'd be right for thinking that. But we did all of this work so that we can now explore different circuits that can be controlled with a transistor. And we'll pick that up in the next video.